if we were asked to calculate the probability involving a binomial random variable, but more than one outcome was possible? Can we calculate that probability? Of course we can. We would need to use the probability of a binomial random variable formula multiple times and find the sum of the different probabilities. Let's try a few problems. In the 2018 to 2019 NBA season, Kevin Durant made 41.6% of his three-point shots. If Kevin Durant took 5 three-point shots in a game, find the probability that he made at least 2 of them. We've already found the probability that Kevin Durant made exactly 2 of them, which was the combination of 5 shots, making 2 of them, times his probability of making three-point shots, 416 thousandths squared, times 1 minus the probability of him making the three-point shots, raised to the third power. And when we evaluate this in a calculator, we get 34.5%. Again, this is for exactly 2 of them. And our question says at least 2 of them. Well, what if he made 3 of them, or 4 of them, or 5 of them? Well, the same principle can be used there. We're going to calculate the probability that he did make 3 of them, 4 of them, and 5 of them. So for 3 shots, 3 three-pointers being made, it's going to be the combination of 5 shots taken 3 at a time, times the probability of him making the three-point shot to the third power this time, times the probability that he misses, raised to the second power. And when we evaluate this in a calculator, it's 246 thousandths, or 24.6%. We can use the same principle for figuring out the probability that he made 4 three-point shots. So again, we're doing the combination of 5 shots, making 4 of them, times the probability that he makes the three-point shot to the fourth power, times 1 minus that probability raised to the first power. And when we evaluate this in a calculator, it's only 87 thousandths, or 8.7%. And then the last one is, well, what if he shoots 5 three-pointers and makes all 5 of them? Well, that one's going to be the combination of 5 shots, making 5 of them, times the probability that he makes it raised to the 5th power, times the remaining probability raised to the 0 power. And that's only 12 thousandths, or 1.2%. Now that we found each of these probabilities, like the probability that he makes 2 three-point shots, probability that he makes 3 three-point shots, probability that he makes 4 three-point shots, and the probability that he makes all 5 of his three-point shots. To figure out the probability of at least 2 of them, well, all of these count, so we need to add all of them up. And when we add all of them up, we're going to get 69%. So the probability that Kevin Durant makes at least 2 of 5 three-point shots is 69%.